Woo, we're going to go back in time. Yep, a while back I told you all about using a factor tree and how it can be helpful and hook you up. So, I'm going to go right here and I'm going to put 30 down. 30, and we're going to break it apart. Snap, snap, snap. Alright, so over here I'm going to list my numbers in order. 1, I'm going to come over here and I'm going to say 30. Okay? Now, when we go to break this thing apart, 1 times anything is that anything. That's why I put a 1 there, and that's why I put the 30 there. The front and the end. Now we need to figure out the other stuff. So, this ends in a 0, but what's the number after 1? The next number after 1 is 2. So, this could be 2 times 15. Okay, I'll take that. Alright, so then I'll come over here and I'll write 30 again. And then I'm going to put a 3 here because the number after 2 is 3. 3 times what is 30? 3 times 10. Okay, I like that. Can I go 4? 4 times something is 30? No, I don't think so. Hey, this ends in a 0, so can I break it with a 5? Yes. Because this ends in 0, I can break it with a 5. Excuse me. So, I'm going to put 30 over here again. I'll put it a little bit higher. Alright, so I'll put my 30 here, and that is 5 times who? 5 times 6 is 30. Okay, cool. And then, oh, what do you notice? It's going to flip, because there's my next 30. And what comes after 5? 6. So that'd be 6 times 5. So it flips, it reverses. So if we go in order, 1 times 30 is 30. 2 times 15 is 30. 3 times 10 is 30. Did we use a 4? No. There's no 4 times anything going to give me 30. But we did use a 5. 5 times who? 5 times 6 is 30. So here's my numbers. Now you're probably like, Mr. Nethercott, why are you doing all this? Because you need it. What's going to happen is this. We have to think of ways to make 3 rectangular prisms that equal 30. Okay, so here's my numbers, and we're going to try to figure out ways. So I'm going to draw my first picture. Now, like I said, the picture isn't important. So, what's a way that we can figure out 30? Now, we said that 2 times, 6. So, 2 times 3 is 6, and 6 times 5 is 30. So, will this work? Yes, because 2 times 3 times 5. And this is 6 times 5 is 30. So, does this work? Yes. It does. Now, what's another 3 digits that will work? Now, didn't you say that we could also make 30 by going, let's see, what's another way we can make 30? We can break that. 3, okay, so we draw another box. The box isn't what's really important, okay? It's the numbers. So if the numbers work, that's what's most important. So if we're trying to figure out ways to do 30, we could say 3 times 10, so that would be 2 and 5. Oh hey, is that right? Because we could say 3 times 2 times 5. What is that? That is 6 times 5, and that also equals 30. So we're doing pretty good so far. Alright. Now, look what we've done. We flipped these. Here we had the 2 and lead, and on the front piece, and then we put 3 here. Then we flip those around. So now we're going to have to do something different. Now we're going to have to pick a different number or numbers to make my 30. So what if I draw my box again? What's another way to make 30? Couldn't we say, if I put a 3 here and a 5 here and a 2 here, even though that doesn't look like it's really greatly drawn, like I said, it's not the picture, it's the numbers that help it. Okay, so 5 times 3 times 2, because 5 times 3 is 15, 15 times 2 is 30. So did we come up with 3 ways to get 30 by doing our boxes? Yes, we did. All right. So, and how did we do this? We did this because we were able to look and say, hey, let's break this apart. Let's take this 30 and break it apart. And let's see what different numbers do I have that I can play with that will make the 30. And then from there, I said, hey, what are three smaller numbers or 3 numbers that I can put together? And what did I use? I used 2, 3, 5, 3, 2, 5. And then this time I said, hey, I'm going to go 5, 3, 2. All right, so all of those, and I chose the lower numbers to make that happen. Okay? I still got more. Sorry.